So this is a quick video just explaining how your book deals with units in the equations and how Iron Sapling deals with units in the equations. So if we look at example 3.3 in the textbook, which is in section 1.2 on instantaneous velocity and speed, your book writes the equation like this. Position, which is a function of time, equals 3.0 times t plus 0.5 times t to the third meters. And what they're doing is they're essentially writing all of the units for the whole equation right here. So everything in here has no units. As your book writes it, everything inside here is dimensionless, and all the units are contained right here. So the number, of course, is dimensionless, but this variable t also doesn't have dimensions of seconds. It is dimensionless. It has no units. Now, that does make it prettier and nicer to write, but it does make it much harder to check your work. So how I, Dr. Milne, and Sapling would write this equation, we would write x is a function of t, and then we'd have 3, and the units here would be meters per second, because we'd be assuming this has units, this t has units of seconds. That would be implied in the fact that this is the variable standing for time, which has units of seconds. And then this quantity would have units of meters over seconds to the third. And then it would be t to the third. And so we'd assume that this whole quantity, the t and the cube, would have units of seconds to the third. So then when you went through and looked at this equation, this first term, it would be 3 meters per second times t, which has units of seconds. So it would be dividing by seconds, multiplying by seconds. Those seconds would cancel out. And the whole thing, the units for this whole thing would be meters per second times seconds, or meters. So you could double check that the units here have the units you expect for a position. And then over here, that would be meters per seconds to the third times seconds to the third, and those guys would cancel out, and you'd also get meters. And so I prefer this way, because then when you're taking integrals and derivatives, you can double check you've done the right thing with the power, because the units should always work out so that things that you're adding, this term and that term, have the same units, meters and meters. You can add them. And then everything on this side of the equation has the same units you're expecting for this. So just be aware that there's a difference. I like this version better, even though it is messier than what your book does. So keep that in mind as you're going through and reading and watching the videos.